Now in this lecture you should learn how to calculate cooling load. So first of all, we focusing on external factors, all external factors through heat transfer in a space. So first of all, we focused on heat transfer through wall. So you learn how the heat transfer through wall, and how we can calculate that heat. So first of all, you see conduction through wall. We have a formula Q equal to UACLTDC. Q is the total amount of heat that transfer through conduction through external wall. So U is the overall heat transfer coefficient. So U is the overall heat transfer coefficient. A is the area of wall, and CLTDC is co-reacted value of cooling load temperature difference. So CLTDC co-reacted value of cooling load temperature difference is equal to cooling load temperature difference, CLTD. So that cooling load temperature difference value, we get this from 6.1 table. Similarly, we have LM. So LM is basically co-reaction for latitude and month, and we get this value from also from table. So 78 is a constant, and minus TR is basically room temperature. Room temperature means that the temperature at the temperature you want to attain in a space, like you have room or anything. So TA is basically the average outside temperature on design day. We should design over day of peak day. So minus 85. So first of all, how we can get value of U, A and CLTDC. So first of all, we see the how we can get value of U. So here you say this is table 6.3, and here on that is display on your screen. So this is description of construction, and these are different group number. So here you see this is 4-inch face brick plus brick. So if you use this material, and we add 4-inch common brick with this, then we have D group, and we the value of U is this 0.415. Similarly, if we use 4-inch face brick, and we have plus heavyweight concrete plus 2-inch insulation plus 4-inch concrete, then we select B group, and the value of U is 0.116. Similarly, from here you select the material that you use in exterior wall. Like we have heavy concrete exterior wall, and in heavy concrete external wall we have 4-inch concrete and 1-inch or 2-inch insulation. Then we have value of U 0.1192.2. So similarly, if we use 4-inch tile, then we have 0.419 point. This is the value of U. So these are different value of U we get from this table. So next we have a area. So we get area of wall by measuring length and height of the wall. So next is CLTDC, which is co-reacted value of cooling load temperature difference, which is equal to CLTD, cooling load temperature difference. So we want to get the value of CLTD. So first of all, we can measure the wall group of wall. So let's suppose we use this 4-inch common bricks in wall, in construction of walls, and we have for this D group. So you can select your group D group, and then you go to this chart. So here you see this is D group wall. So now we see the orientation of wall. So let's suppose we have north orientation of wall, then we draw this line horizontally, and then here you see these are solar time. So we should set the peak solar time where we have maximum heat. So it's approximately 15 o'clock. So we select this, and 12 is the value of cooling load temperature. So in this way we measure the value of cooling load temperature difference from the table. Similarly, next we have value of Lm. Lm is here you see co-reaction for latitude and month. So now we get value of Lm from also from this table. So this is a table. Here you see these are different latitudes. Let's suppose our city lie on 40-degree latitude. Then you can see in this table, and June 20 June is the day where we have uh, peak heat like 120 Fahrenheit. So now we measure this peak June month, the peak month, and then from here we measure the orientation of wall. So let's suppose our wall is on north, then we measure this. So 1 is the value of Lm. Now in this way we can measure the value of Lm. So similarly we have next value of Lm latitude month. We measure the value of CLTD. TR is the design room temperature. It may vary from 68 to 75 and depends on the how much cooling you required. So TA you can also write here the average outside temperature. So the outside temperature is we can measure with this formula T naught minus dr by 2.